All right, so thank you for joining me again. We're going to talk about what is a polygon. So polygons are geometric shapes. There's lots of geometric shapes. Let's start with an example of something that's not a polygon. It's a circle. Now, what makes this not a polygon? Well, for one thing, it only has one edge. And that edge, that one edge we have, is not straight. Okay? So first and foremost, when we talk about a polygon, let's just say good old Mr. Triangle there, it has to have straight edges to it. And it has to have three or more. It's impossible to make a polygon with just two edges. It's impossible to make a polygon with one edge. You have one edge, you're just simply talking about a circle, or you're talking about a straight line, or you're talking about some type of curve. So in that case, so if you're talking about a closed figure with one edge, you're talking about a circle or an ellipse. Those are your two options. What's interesting is my 6-year-old actually made the statement, oh, an ellipse is just a circle that's been stepped on by an elephant. One of the best descriptions I've ever heard of an ellipse before. But anyway, what's really interesting is that a circle is actually a special case of an ellipse, but neither of these are polygons. Okay? These are actually what we call conics. So you're like, they have a classification? They sure do. These are two conics. In fact, this is the conic section, and this is a special case of that conic right there. Not really what we're talking about today, but just a little bit of background so you can see it. Now this one over here, this is a triangle. This triangle is indeed a polygon. Now what makes it a polygon? What makes it a polygon is it has three or more edges. Now the thing is, we really need to qualify these edges. These edges need to be straight. Okay, so a straight arrangement of points, a continuous straight arrangement of points is what we call a line. So when we say we have a straight edge, that actually, I'm going to put another polygon around that like that maybe. That's not really a polygon, and I'll talk about that in a second. This is actually what we call a side. So really what we're saying there is it has to have three or more sides. Now there's something else going on here. I just said that what I drew there wasn't a polygon, because this right here, there's a gap there. It must be what we call closed. Meaning, it's essentially creating a fence line. If I had sheep in here, my sheep could escape. I don't want the sheep to escape. Sheep can't defend themselves against they can't defend themselves against practically anything. I've seen sheep get scared out of their minds over a twig, right? So we need to keep our sheep inside of the fence line, which means it needs to be closed so they can't escape and they can stay safe and the twigs won't attack them and kill them, right? Now, what are other polygons we have? Well, we have quadrilaterals. Good old Mr. Quadrilateral there. And it's closed, right? Now then, beyond this, we have other types of polygons that we should talk about. We have pentagons, hexagons, and all down the line. It just simply means we add more and more sides. And you really should be versed on those names all the way up to about 9 or so, maybe 10 or 12 if you want. They keep going on and on after that, in fact. But they can have an infinite number of sides, really. But this is the idea. So we have quadrilateral. Now, there's lots of different quadrilaterals that we should have a discussion about. Now, one of the big things that we need to discuss first is the difference between a convex and a non-convex polygon. What does a convex mean? Well, basically what it means is that if you were to draw, and the easiest one I can think of is a shape like this, which means we have 1, 2, 3, 4, 5 sides. So this is a pentagon. But this is non-convex because any 2 points I pick, it looks kind of like a cat now, doesn't it? I pick any 2 points in that polygon, I should be able to draw a line from point to point. In the line, the entirety of the line stays inside of the polygon, not here, okay? Because it's actually concaved in. So the convex polygon simply means that when I draw my shape, okay, so this is closed, right? It has straight edges, it has more than 3 of them, and it's convex because any 2 points I pick a point there, and anywhere else I pick that point. There's nowhere to draw that point, so that when I draw that line, that pathway between those 2 points, I move outside of the figure, okay? And this has a lot of applications in different ways, but really this doesn't mean that this particular polygon is bad. We shouldn't shame it. There's nothing, it hasn't done anything wrong. All we're doing here is we're just pointing out the fact that this is a special type of one. One of the big, most important aspects of this is this fits a pattern with the sum of its interior angles. This does not, because it has at least one obtuse angle here. And as soon as we introduce that obtuse angle like that into this shape, and of course this one has obtuse angles as well, but when we do this, when we produce this obtuse angle as greater than 180 degrees, we have problems. And that's really issues. I guess I shouldn't say obtuse, because it's not obtuse. It's greater than 180. Well, as soon as we introduce that angle is greater than 180 degrees, we start getting into all sorts of really interesting things that happen that don't fit the mold and they're not predictable. Like, for instance, I can draw another pentagon like this. Okay, close the edges there. And now this pentagon has the interior, if we were to figure out the angles of those interior angles, the sum of those interior angles, those sum of those 5 interior angles is going to be greater than the sum of these 5 interior angles, because this angle is greater than that. I can get this almost to the point where, if I were to draw this in the correct way, I might even be able to get this angle to be 159 degrees. I couldn't do 360, because then it would close the top off. But as long as it's 159.9 degrees even, I can make the angles of this thing really, really massive. The sum of the interior angles anyway. This one, not so. This one is set 540. A convex set, the sum of these interior angles is always going to be 540 if it's convex. We don't know what it's going to be if it's non-convex. Okay? Which is a really important thing for us to acknowledge. And that's why when we talk about polygons, we're normally going to be using convex polygons, because the predictability and the usefulness in what we're talking about. A lot of these rules and a lot of the definitions and a lot of the theorems that we're using and properties that we're talking about fall apart when we deal with non-convex. But non-convex have their usefulness, and they're actually they have their own set of things that we can work with as well. But in this course, we're not going to be dealing with that. All right, and then there's lots of other things we can do with polygons as well, in terms of finding areas and doing all sorts of other really neat and interesting things with them, finding angle measurements and setting up problems with them. There's lots of usefulnesses in regular polygons and convex polygons, and keep in mind that regular polygons are a type of convex polygons. Regular just simply means that all the angles are congruent and all the sides are congruent as a result. All right, thank you.